Okay, so here we are in Geometry, Chapter 7, Section 4, applying properties of similar triangles. Pause and try these. Let this warm up on your own. So hopefully you reduce this 12 over 15 to what?
3 over 4, or 4 over 5.
4 over 5, and 5 times 4 is 20, so 3 times 4 is...
No, 4 times 4.
I'm sorry, 4... This here is...
Divide by 3 is 4.
4 over 5, right?
Yeah.
5 times 4 is 20, is what I said. And what was the top?
You said 4 times
3?
4?
Whatever I
You
said, it should be 16. 4 times 4, sorry. Okay, how about this? Did you blow this up to 38 over 42?
Yeah.
And then shrink it down?
Oh, I did 38 over 42 and 95 over 42.
Okay, could you shrink 38 over 42 down?
Yeah. Oh.
And it would become what? 19 over 21? You could do that, 19 over 21.
Oh, I didn't even think about doing 2.
Okay.
No, I thought about it, I'm like, eh.
And what did you get, Blake?
I got 10.2, but it's because I did it right.
It should be. Did anyone get 10.5?
Oh, I got 105.
And that's because you blew up the 9.5, but you've got to shrink it back down. Okay, this one becomes a little more fun because you get to distribute these things. And Joey, what do you have for X?
I got, it is 21.
Do you agree?
Yes.
21. And how about here? A little more fun. Oh, did you blow this up? 3.5
Oh, no, I didn't vote this one.
over 2.8? Again, this is 35 over 28.
I
5
refuse.
fourths.
So you can divide by 7s and end up with 5 over 4,
Oh.
right? So any chance you get, simplify that way. And what do you have, Amaya? 8. Good job. Okay, the objective today is we're going to use properties of similar triangles to find segment lengths. We're only working really on the first objective today. Tomorrow you will apply proportionality and triangle angle bisector theorems. That's tomorrow. So today we're looking at similar triangles to find their properties in order to find segment lengths. So we have a theorem and its converse today. And the theorem is the triangle proportionality theorem. So on the quiz, you were just looking at this sort of a thing.
That's right.
Okay? So this will be helpful if you face that again. You know what? It doesn't matter. You could solve that on the quiz using what you knew already.
Yeah.
Okay? But this says that if a line parallel to a side of a triangle intersects the other two sides, you can see EF intersects AB and AC, right? And it's parallel to the third side BC. Then it divides these two sides, AB and AC, into, a proportion. So look at this. AE over EB equals AF over FC. And that's because this is a parallel intersecting line. Okay? So the other one, the converse, without going there and looking at it in your notes, the converse would be, what do you think? I want to see if you can stretch your thinking here. If the
two sides are proportional,
if an intersecting segment
is parallel to the base.
very good. So if an intersecting line results in proportional sides that are divided proportionally, then you can prove lines parallel this way as well. We're going to see that in a moment. Okay? So let's see if we can find the length of a segment, US. Okay, so raise your hand if you have a comment. You're too talkative. Tell me how you can set this up, and there is more than one way to set it up. Like,
I did 10 over 4 equals 14 over X.
good, so he's labeling this segment USX, and he's saying 10 over 4 would equal 14 over S. Can you set it up differently?
Yes.
Alyssa, how can you set it up differently?
I did 4 over 10 equals X over 14.
Okay, so she did 4 over 10 equals X over 14. And so we're finding that X, and what did you get, Blake?
I got 5.6.
Do you agree, Amaya? They're setting this up the way that Alyssa did in this example here. They said US over 14 equals 4 over 10. And so do you have the same value as Blake? All you have to do is use your cross product. I don't see the answer.
Yeah,
Oh, what did you say it was? 5?
5.6, so 5 and 3/5.
And 5.6 is this, isn't it? 5 and 3/5. Okay, very good. Let's try it again. Find PN. It's easy, isn't it? And I'm going to ask Joey how you're setting it up.
Okay, so I'm going to put 3 over x equals 2 over 5.
Okay, so he has 3 over x. And how are you choosing to solve this one?
I am cross products.
Okay, so you end up with what?
15 equals 2x, and then x equals 7.5. Or PN.
So the missing side PN equals 7.5. Good. So here's the converse, which you already predicted. Okay. The converse of the triangle proportionality theorem states that if a line divides two sides of a triangle proportionally, it is parallel to the third side. So here's a way we can prove something parallel, which then we can use angles, corresponding angles or whatever, alternate interior, same side interior. Okay? So this looks as though DE is parallel to BC. And Blake, tell me how to set up proportions to prove it.
10 over 15 equals 8 over 12.
So if we're testing it, I'm going to put a
Yeah.
question mark. Does that equal 8 over 12? And so when you reduce 10 over 15 down, what do you get?
2/3.
Is that the same as 8 12?
No.
Oh
Okay,
my
yes,
God.
sorry, yes, I meant yes.
That was
Yeah,
we forgive.
I was- I
That
had the
was-
button on my moment.
Sorry.
Okay, so
Sorry.
by showing the proportionality of the two sides, which are being intersected by DE, we can prove that DE is parallel to BC. Good. Okay, and then this is the final corollary that we're talking about today, and this is it. And that is, what if we added another transversal? So if 3 or more parallel lines intersect 2 transversals, then they will divide the transversals proportionally. Actually, that's not quite how I stated it, is it?
So it's 8.
If you have 3 or more parallel lines with transversals,
Oh, yeah. It's like the same thing almost, but it's not a triangle. The lines
Well,
make a trapezoid.
It does form a triangle
Eventually.
eventually, good. So what I'm hearing these students say is, we could extend these lines out and we would have a big old triangle out here. If we made a point out here in which these intersected, they're gonna intersect because they're not parallel.
And also would be proportional.
Good, so we would have all these pieces that are proportional. Good. So this first example, this art application, I left it open so you could follow the steps. And then the second one is an opportunity for you to solve for something. Okay? So let's read through this first one. Suppose, this is often used, these parallel lines with transversals can be used when drawing proportional pictures, or pictures that have, in art, what's the word you use? A picture that has, it's another P
It's,
word, but it's not,
perspective.
it's perspective. Okay, so do you see how, have you learned that in art? Where you can put a point at the end of the page and all lines kind of go to that point? Good, okay, so you've had that experience. So suppose an artist decided to make a larger sketch of the trees. In this figure, AB is 4.5. You can see BC is 2.6. CD is 4.1.
Oh,
And then what do we have?
transversal.
KL is 4.9.
Yeah.
So how can you find LM, Amaya?
Well, 4.9 over 4.5, and then
That's interesting.
what?
She is setting this up differently than what we just saw. She's saying 4.9 over 4.5. You could, there are like 8 ways to set up proportions, so this is probably one that will work as well. If you say 4.9 over 4.5, what will you say then? Equals what?
Maybe
I know it.
2.6 over x.
Ooh, I don't know, you better be careful. Because this is really the two side,
Yeah.
4.9 over x equals 4.5.
for 2.6. That's one way to do it. Or you could say, given what you just said, you said 4.9 over 4.5 probably equals x over 2.6.
Oh, that's
Right?
what I meant to say.
You said it the opposite way. Okay, let's see how they do it to find LM, because this one's been done for you. They say 4.9 over X, the second way Amaya stated it, right? Equals 4.5 over 4.6. So they find LM is 2.8, which do they use? No, they don't use to find the next. You know, you can use 4.9 over MN, do you see that? Equals 4.5 over 4.1. So we can even remove this segment between them, and we still have proportional relationships between these segments, okay? So here's your chance to try this. Using this diagram, find LM and MN.
Wait, which one?
We're on example 3.
Poof. It's a Joey.
Okay, so use the
The
diagram
one
to
of
find
Joey enters the
LM
woods.
and MN to the nearest 10.
Extend
So
your,
you
the microphone is in front of you out here.
So you can put 2.4 over 2.6 equals, don't judge me, 1.4 over X to figure out LM. So it's 2.4 X equals.
We're finding both. Look at the question. Did anybody blow up 2.4 over 2.6?
Yes, I did.
Call it 24 over 26?
And then,
I don't like.
I have a calculator.
You could still leave 1.4 alone, right? And you'll find the exact value. If you blow up the
I did it
1.4, don't
wrong.
forget to shrink it, your X value down.
So, Stephen, and then divide that by 2.4. And you can divide both by 1.2. So this equals 2.
Wait, don't you have 3.64 in the numerator?
3.6, oh, 6.4. Yeah.
So I don't know if you want to do that reducing, so let me back you up, because it's not really 1.2 that can go evenly
I thought
into
that's
them.
a y. Okay, so then you just divide into it. Where 2.4 goes into 3.61.
Are you going to leave your decimal in 2.4?
No. So I'm breaking down.
The pressure of standing in front of.
Much.
And
people.
now 24 into
It's
124.
not 6, it's 5. You have to make it 5.
oh, are you doing something?
Wait a minute, wouldn't it go in 6 times?
Would 6? No, it'd be
Yeah, because 24 times
12.
4 is not 100, huh? Oh, I'm sorry, 5, I'm thinking 5. 24 times 4, so it's 5.
So 4 times 4 would be 96. So it'd be 126. So times 5. And you'd still have 4 remaining.
Okay, so we have approximately,
1.5.
put that decimal in there.
Label always.
Yeah.
Unfortunately, we're running out of time. We only have less than a minute left.
About 1.5.
Okay, 1.5, and we still need to find MN, so come back and see what they got for MN.
So I took 1.4 and put it over 1.5, which we just found, and that equals 2.2 over MN, which is what we are finding. And then it's 3.3 equals 1.4x. What am I doing? You get the cross products, and then you divide by 1.4, and you get 2.4 equals x. Yeah.
So MN is X in your video. Okay.
Yes.
Okay, and so you are ready to go with a lesson quiz. And pause, come back and check it, because we're out of time. And okay, you can only really do number 1 because we haven't talked about number 2, and your answer 16 and a half. Very good. And your assignment. Time is up.